Hello everyone. Today we are going to discuss lecture number 21, armature reaction in synchronous machine. In this lecture we will discuss how armature reaction plays its role in the MMF and flux of the main field winding. When an alternator is running at no load, there will be no current flowing through the armature winding. The flux in the air gap will be only due to the rotor ampere turns. When an alternator is loaded, the three-phase currents will produce a total magnetic field in the air gap. Therefore, the air gap flux is changed from no load condition. The effect of armature flux on the flux produced by the field ampere turns is known as armature reaction. We have to note this thing. This is the definition of armature reaction. It is the effect of armature flux on the flux produced by the field ampere turns is known as armature reaction. Dear all, we know that armature winding is on stator in the alternator and field winding is on the rotor. So armature winding is on the stator and field winding is on the rotor. So whenever there is load connected, stator winding is also having current flowing through it. Therefore, the flux produced by the armature flux is known as the armature reaction. Two things are noteworthy about the armature reaction is that number one, the armature flux and the flux produced by the rotor ampere turns rotate at the same speed in the same direction, and therefore the two fluxes are fixed in space relative to each other. The second thing is the modification of flux in the air gap due to the armature flux depends on the magnitude of the stator current and also on the power factor. So this is very important point to note, that the effect of the armature flux depends on the magnitude of stator current and the power factor of the load connected. This is very important to note because it plays very important role in the armature reaction. If the load factor is depending upon the load factor, it will be decided whether the armature flux distorts, opposes or helps the main flux produced on the rotor. Number one, there are three cases. Number one is when the load power factor is unity. As we see in the diagram, when the load power factor is unity, the armature is open circuit, there is no current flowing and the flux due to rotor current is distributed symmetrically. However, when the load unity power factor load is connected, the flux produced by the armature plays an important role. According to the right hand rule, the current in the conductors at the north pole is inside and the current in the south pole is outside. So the flux is clockwise due to the current in the armature. So this is shown in the figure 2 here. Now the armature flux is clockwise due to currents in the top conductor and anti-clockwise due to the current in the bottom conductor. Note that the armature flux is 90 degree to the main flux and is behind the main flux. Therefore, the flux in this case plays to distort the main flux, not weaken. It distorts the main flux. Therefore, at unity power factor, the armature reaction is to distort the main field flux, and there is no weakening of the main field and average flux practically remains the same. So this is the armature reaction when the unity power factor load is connected. When the load power factor is zero lagging, then what happens? As the load is purely inductive, so the current condition when the alternator is supplying to resistive load, the EMF as well as the current is in phase is maximum. When alternator is supplying to pure inductive load, the current in phase R1 and R2 will not reach its maximum until north pole is advanced to the electrical as shown in the figure 1D. The figure 1D is shown here. So this is the R1 and R2. These are the two points shown here, and the for the lagging zero lagging power factor, you will note that the armature flux is from right to left and field flux is from left to right. As the all flux produced by the armature current opposes the field flux, therefore it weakens the main field flux. Hence, the armature reaction is directly demagnetizing in the case when the load connected is zero lagging. So, the third case is when the power factor is zero leading. This is the pure capacitive load case. When the load is purely capacitive, then the current in the armature winding will lead the induced EMF by 90 degree. Obviously, the armature reaction will reverse that of the purely inductive. Therefore, the armature flux now add to the main field flux and the generated EMF is increased. It is shown in the figure previously we discussed. So these are the three cases we discussed, that when the armature number one is when the unity power factor load is connected, the armature reaction is to distort the main field flux. Number two, when the load is lagging power factor connected, then the armature reaction weakens the main field flux, and when the leading power factor load is connected, then the armature reaction adds to the main field flux. So this is all about the armature reaction in the alternator. And as we all know that purely capacitive, purely inductive loads physically, practically is not in the existence. So always there is either lagging or leading power factor load is there. So there is some phase difference between the voltage and current in the armature, and therefore either it will aid or weaken the main field flux. So this is all about the armature reaction in the alternator. Thank you very much.